Welcome to CTI 141, Cyber Safety Lesson 4. Today's lesson, titled Trust Nothing, Recover Everything, explores how organizations can build secure, resilient cloud architectures designed to withstand the unpredictability of digital threats and operational failure. In our cloud-driven world, trust is not granted. It is earned through verification. We'll examine how zero trust principles and strong backup strategies are essential to safeguarding data and ensuring service continuity even in worst-case scenarios. This lesson is not just about technology, it's about mindset, planning, and adaptability in the face of uncertainty. This lesson has 5 primary objectives. First, you'll learn what the Zero Trust security model is and why it's essential for cloud environments. Then we'll explore how to apply identity and access management (EIM) practices to reduce the surface area attackers can exploit. Next, we'll walk through designing resilient backup and recovery systems that can bring systems back online swiftly after disruption. We'll also identify key cloud tools that enable fault tolerance and business continuity. Finally, we'll analyze real-world case studies where cloud systems failed and how smarter design choices could have minimized the impact. Before diving in, pause and reflect on what you currently know about cloud security. Think about your experiences with cloud systems, whether as a user or administrator. What security practices do you already understand? What gaps might exist in your knowledge about zero trust or backup recovery? Make a list of what you're confident about and what you're uncertain about. This self-awareness will help you track your learning journey throughout the lesson. Zero Trust is a cybersecurity model that starts with the assumption that no user or device should be inherently trusted, whether inside or outside your network. Every access request is treated as potentially malicious until it's verified. This means continuous authentication and strict access controls based on the user's identity, the security posture of their device, and the context of their actions. Zero Trust also requires visibility into user behavior and rapid response mechanisms to isolate or shut down suspicious activity. It's a proactive, defense-in-depth model suited to the decentralized nature of cloud environments. The cloud is borderless. Employees access systems from their homes, cafes, and mobile devices. This decentralization makes traditional perimeter-based security obsolete. A zero-trust approach limits lateral movement. If an attacker compromises one account or device, they can't pivot through your environment. It minimizes the blast radius of any breach by tightly controlling what each identity can do and see. It also supports modern work models like BYOD and remote collaboration by ensuring each session is independently validated. The core pillars of Zero Trust are identity security, device security, network segmentation, and application security. Identity security ensures that users are authenticated using strong methods like MFA and federated identity systems. Device security ensures that only devices that meet compliance standards can access the network. Network segmentation limits each user and device to only what they need. And application security enforces strict, role-based access control. Together, these layers provide comprehensive, adaptive defense across all cloud environments. Cloud resilience means designing systems to not just survive failures, but to recover quickly with minimal disruption. This involves using redundant infrastructure, automating recovery workflows, testing backups, and distributing workloads across regions. Think of resilience as an immune system for your cloud. It detects damage, contains it, and restores normal function as fast as possible. The goal is not to prevent every failure, but to limit the impact when, not if, it happens. A robust backup strategy uses a mix of backup types and locations. Full backups create complete copies of systems. Incremental backups save only changes, optimizing space. Snapshots preserve system states for fast rollback. Off-site backups protect against regional disasters. The key is alignment. Backups must match business requirements for data retention, speed, and availability. Good backup strategies also incorporate versioning, encryption, and automation to reduce human error and strengthen security. Full backups are the gold standard of data protection. They include every file, configuration, and system state, providing a clean slate for recovery. However, because they are resource heavy and time consuming, they're typically performed weekly or monthly. Their strength lies in their completeness. If your system is wiped or corrupted beyond repair, a full backup is your best path to a clean restore. They're also critical for compliance, especially in regulated industries that require full audit trails and recoverability. Incremental backups capture only the data that has changed since the last backup. This makes them much faster and more storage efficient than full backups. However, they add complexity to recovery, as the system must rebuild the full state from a chain of incremental files. This makes proper scheduling and monitoring essential. Still, their efficiency makes them ideal for dynamic cloud environments where changes happen rapidly and often. Snapshots are instant captures of a system's current state. They're widely used in virtualized environments because they're quick to create and roll back. Think of snapshots as temporary save points. They're ideal for rolling back after a failed update or malware infection. However, they shouldn't replace backups. Snapshots typically reside on the same infrastructure they're protecting, meaning they could be lost if that infrastructure fails. Use them for short-term recovery and system testing, not long-term retention. Off-site backups are critical for disaster recovery. By storing data in a different region or even a different cloud provider, you protect against physical threats like fires, floods, or regional outages. Many organizations use cross-region replication tools like AWS's S3 replication or Azure's geo-redundant storage. Off-site backups also help meet data sovereignty laws, which may require data to be stored in specific jurisdictions. Without geographic diversification, a local disaster could wipe out both production and backup data. Recovery time objective, RTO, is how long you can afford to be down before the business suffers. Recovery point objective, RPO, is how much data you can afford to lose. Service level agreements, SLAs, define what your cloud provider guarantees in terms of uptime and recovery. Knowing these metrics helps you design backup strategies that match your business's tolerance for disruption. They're not just technical values, they're business imperatives. In 2023, a major cloud provider's routing bug and hardware failure caused hours-long outages for thousands of businesses. Those relying on a single region were hit hard. Those with multi-region failover barely noticed. This incident illustrates the importance of designing for failure. Assume that every service can and will fail eventually. Architect your infrastructure with that mindset, and you'll be ready to maintain continuity when disaster strikes. Credential stuffing, phishing, overprivileged accounts, and missing MFA are among the most common access-related threats. Attackers exploit weak identity practices to gain unauthorized access. Implementing least privilege, enforcing MFA, and monitoring login behavior can shut down most access-based attacks before they start. The best defense is a layered one. Prevention, detection, and response must all work together. AWS Backup, Azure Backup, and Google's backup and disaster recovery tools all offer powerful features like lifecycle management, encryption, and cross-region replication. However, they require configuration. Nothing is automatic. You need to define backup schedules, retention policies, and recovery plans yourself. Understanding the capabilities and limitations of each provider's toolset is critical to ensuring they work for your specific needs. Backups must be monitored to ensure they're working. Enable automated alerts for failed or incomplete jobs. Use dashboards to visualize trends and catch anomalies. Integrate with SIEM tools to detect patterns that might indicate deeper issues like malware wiping out backups. Simply having a backup job isn't enough. You need to know if it ran, if it succeeded, and what to do if it didn't. A sample cloud backup policy might include daily full backups, off-site storage, and email notifications to admins. Policies like this ensure consistency across systems and team members. Everyone knows when and where data is being backed up and who to contact if something goes wrong. Documented policies are also critical for audits and regulatory compliance. Restoring from backup is the real test, not making the backup. Simulate full system failures to validate that you can recover quickly. Test for data integrity, configuration accuracy, and operational functionality. Document everything: how long it took, what worked, what didn't. Run tests monthly and update your recovery runbooks accordingly. Backup testing is where theory becomes practice. Business continuity goes beyond IT. It's about protecting operations. Plan redundant internet and compute paths. Prioritize critical systems and map dependencies. Train your team with realistic exercises. When disaster strikes, your people, not just your tools, must be ready. A good plan ensures not just recovery, but resilience, customer trust, and regulatory compliance. Redundancy strategies include replicated storage, multi-zone DNS, failover databases, and load balancers. Replicated storage ensures data availability. DNS redundancy keeps services discoverable. Failover databases maintain continuity. Load balancers prevent overload and redirect traffic from failed servers. These are not just technical luxuries, they are foundational components of resilient cloud design. Measure backup success rates, actual restore times versus targets, missed backup instances, and SLA adherence. These metrics offer visibility into whether your resilience plan is working. They help you spot issues before they cause failure and validate that you're meeting internal and external expectations. Metrics turn guesswork into accountability. Many assume that SaaS providers back up their data automatically, but that's rarely the case. Deleted files in platforms like Microsoft 365 may be lost forever after a short window. In 2022, a business lost critical data because they didn't realize this. Always verify what your SaaS provider offers and supplement it with dedicated backup solutions if necessary. After an incident, conduct a root cause analysis. Was it a technical error? Human mistake? Document everything. Patch the problem. Update policies. Train your staff. Turn your incident into an opportunity for improvement. This cycle of learning and refining builds a stronger organization each time. Myth: the cloud backs up everything. False. Myth: snapshots are backups. Also false. Myth: SaaS handles recovery. Not always true. Each of these misconceptions can lead to irreversible data loss. The truth is, you are responsible for understanding your environment and actively managing your backup and recovery plans. Cloud security is shared. Providers protect the infrastructure, but you protect what you deploy. That includes your configurations, data, applications, and backups. Ignoring this leads to compliance failures, security breaches, and costly downtime. Know where your responsibility starts and act on it. A good recovery plan doesn't have to be complex. Identify your critical systems. Set RTO and RPO goals. Define your backup schedule. Assign roles and create a communication plan. This clarity ensures that when a crisis hits, everyone knows what to do, and nothing important is forgotten. A multi-cloud strategy reduces risk by spreading workloads across providers. If AWS fails, Azure keeps running. Open source tools like Kubernetes and Terraform help manage these environments. Interoperability testing ensures your systems won't break during failovers. Multi-cloud is not just redundancy, it's agility. To succeed in the cloud, plan for failure. Use zero trust to limit damage. Secure and test your backups. Continuously optimize IAM. This lesson emphasized proactive architecture and rapid recovery. These principles will help you build a cloud strategy that's not only secure but resilient by design. Revisit your original list. How accurate was your understanding of zero trust and backup strategy before this lesson? What did you learn that surprised you? Use this reflection to reinforce key takeaways. Growth begins with awareness and continues through practice. Congratulations! You've completed Lesson 4. You now understand what it takes to build resilient, secure cloud systems that can adapt to failure, recover from attacks, and deliver trust even in the most unpredictable scenarios. Carry these insights with you as you architect your own cloud environments.